Okay, now. Today we're going to discuss higher order linear differential equations with constant coefficients. The method that we're going to use, auxiliary equation method. So last time in the video that I asked you to watch, so you were introduced to differential operators. The differential equations that we're going to have most of the time are written or expressed in terms of differential operators. So you must know very well how to handle or how to use such operator, okay? So if you have forgotten, you can go back to the video so that you can recall so what differential operator is and how it is used, properties of differential operators, and also the operations that you can have for differential operators, okay? So again, this is auxiliary equation method of solving higher order linear differential equations with constant coefficients. The general form of a linear differential equation with constant coefficients takes the form b sub 0, y of order n, b sub 1, y of order n minus 1, so meaning derivative of order n minus 1 with respect to x, b sub 2, y of order n minus 2, all the way to b sub n times y, and that is equal to r of x. So this is the general form of a linear differential equation with constant coefficients. In denotation, this is equivalent to b sub 0 d to the n plus b sub 1 d to the n minus 1 plus b sub 2 d to the n minus 2 all the way to b sub n, then applied to y equals r of x. So d to the n here means derivative, nth derivative with respect to x. And of course the d, derivative with respect to x, and that is an operator, differential operator. B sub i's here are all constants, where I equals 0, 1, 2, all the way to n. So, meaning b sub 0, that's my b sub I. B sub 1, another b sub I. B sub 2, so that is when I is 2, so b sub 2. Until we get the last term, we have b sub n, meaning, so that is the I, no? And that operator, b sub 0 t to the n, all the way to b sub n, is to be applied to y, meaning you're going to get the derivative of y of order n. And the right side is in terms of x. Methods of solving linear differential equations with constant coefficients. So we can use auxiliary equation. You can also use undetermined coefficients and then variation of parameters. These are the commonly used methods of solving higher order linear differential equations with constant coefficients. Homogeneous linear differential equation with constant coefficients. Now, in differential operators, a video that you had, we have the following, no? Yan. But by the way, I have to correct this. So, I actually have the correction in the video. This is supposedly 12. I do not know why the last term, why it is d squared plus 4d minus 3. It is supposedly d squared plus d minus 12 applied to y equal to 0. That particular example. I corrected that already in the video. I had a comment there for the correction of the problem. But the the solution is correct, except that the problem is not supposedly d squared plus 4d minus 3. And the factored form of d squared plus d minus 12 is d plus 4, d minus 3 applied to y equal to 0. And for d squared minus 8d plus 16 applied to y equal to 0, this is equivalent to d minus 4 quantity squared applied to y equal to 0. But remember so this is not really exponent, no? It means order. So when I say d squared, it means second derivative with respect to x. We are allowed to read it as exponent, but bearing in mind, so it means order and not derivative and not exponent, okay? And then we had also in the example, d squared plus 4 applied to y equal to 0, and that is equivalent to d plus 2i, d minus 2i applied to y equal to 0, where I here is an imaginary number in this case, no? And general solution of this, as what we had in the discussion in the previous video, so are the following, no, respectively. So the general solutions for these three are this respectively, no? So for d squared plus d minus 12 applied to y equal to 0, when you solve that, the solution is y equals c sub 1 e to the negative 4x plus c sub 2 e to the 3x. Remember, in the elimination of arbitrary constants, if you're going to eliminate c1 and c2, what you will get is a differential equation which is y double prime plus y prime minus 12y equal to 0. So in prime notation, d squared plus d minus 12 applied to y equal to 0 is equivalent to y double prime plus y prime minus 12y equal to 0. And as I said, if you're going to eliminate the arbitrary constants here, so that's what you will obtain, okay? So in similar manner, if you are going to eliminate C1 and C2 in this second general solution, what you will get, y double prime minus 8y plus y double prime minus 8y prime plus 16y equal to 0. Okay? And then for the third one, so if you have y equals c sub 1 cosine 2x plus c sub 2 sine 2x, so if you eliminate c1 and c2, what you will get, second derivative of y with respect to x plus 4y equal to 0, or that is y double prime plus 4y equal to 0. Okay? Now, it is already explained in the first video how c1 cosine 2x plus c2 sine 2x is obtained from this, no? Y is k1 e to the negative 2ix plus k2 e to the 2ix. Again, here I is an imaginary. Y it is equivalent to c1 cosine 2x plus c2 sine 2x. Okay? So, associated in this differential equation, so especially the left side, so you have m plus 4, m minus 3, then equal to 0, no? So again, associated in this differential equation is a polynomial equation, let's say in m, and that is given by m plus 4, m minus 3 equal to 0. So notice that I just replaced d by m. So, and if I'm going to solve the roots of this equation, I will get m equals negative 4, m equals 3. And in a similar manner, so for d squared minus 4, quantity squared applied to y equal to 0, the associated polynomial equation, which is specifically quadratic equation, m minus 4 quantity squared equal to 0. If you have the associated polynomial equation, you do not include any more y, you just replace d by m or any letter you want, except of course by d, but normally we use m for auxiliary equation, no? And remove y and then equate to 0, then you will now have the associated polynomial equation. If you solve for this equation, we get m equals 4. So which is of multiplicity 2, meaning it is a double root in quadratic equation. So you get m equals 4 twice. And then if you have d squared plus 4, apply to y equal to 0, the associated equation is m squared plus 4 equal to 0. But when you factor that equation, it will give you the left side, it will give you m plus 2i, m minus 2i equal to 0. Okay? Or you will get m squared equals negative 4. And then when you solve for m, plus or minus 2i. Okay? So, and if I'm going to get the modulus of that, it will get you the absolute value. Actually, that's the modulus of this imaginary number, and that is equal to 2. So we are interested, pag imaginary, we are interested to its modulus, okay? So, and that is equal to 2. For instance, the modulus of 2 plus I, that is square root of 4 plus 1, and that is square root of 2 is 2 squared, that is 4 plus 1, so square root of 5. Modulus of 2 plus I. Okay? So, notice that these roots are exponent of E in the general solution. Like for instance, m equals negative 4, that is exponent of the first E in this solution. No? And then 3, it is the exponent of E in the second. And notice that also in the second solution, so this 4 is what? Exponent of E. So which is e to the 4x, no? Yan. And then just multiply by x. And this modulo, if it is, if the solution is y equals c1 cosine 2x plus c2 sine 2x, the modulus is the coefficient of x in the argument of cosine and sine. But if it is in exponential form, it is the exponent of e also, but the actual roots. 2i and then negative 2i. For the first term, you have negative 2i, then multiply by x, positive 2i, then multiply by x. This gives us the idea of having the solution for homogeneous LDE with constant coefficients, that all you have to do is to solve the roots of the associated equations and make it exponent of E. Okay? Now, every term has an E factor. Okay? And the exponent of E, one of the factors in the exponent of E is the root. Yan. Okay? So, let's now discuss such method. So we call that method of auxiliary or characteristic equation. This is applicable to any homogeneous LDE with constant coefficients. By the way, guys, are you still there? Guys, I'm checking because to make sure that I am not lost, no? Because I might lose connectivity with the internet or with you. So again, this is applicable to any homogeneous LDE with constant coefficients of the form b sub 0 d to the n plus b sub 1 d to the n minus 1 plus b sub 2 d to the n minus 2 plus plus b sub n minus 1 d plus b sub n applied to y equal to 0. Now, notice that the right side is 0 because I mean homogeneous LDE. Remember in the discussion in the differential operator video, so what homogeneous LDE with constant coefficients is? No? Homogeneous meaning the right side is 0. Okay? By the way, there is a recording of this also in the YouTube, but there is only music about that, showing the file, the contents of the file with music, but no voiceover. Okay? So if you want to see that, you can visit the YouTube. Now again, b sub i's here are all constants where I is equal to 0, 1, 2, 3, and so on up to n. So b sub 0, b sub 1, b sub 2, all the way to b sub n. So for simplicity, we're going to call this f of d applied to y equal to 0. Again, f of d meaning a function in terms of d. This differential operator is to be called f of d, meaning a function in terms of d, operator in terms of d. Then apply to y equal to 0, this is the linear DE, homogeneous linear DE. Pag ang right side is not 0, it is non-homogeneous LDE. But method of auxiliary equation or characteristic equation is applicable to right side LDE whose right side is equal to 0. Now, associated in this differential equation, f of d applied to y equal to 0, is a polynomial equation, b sub 0 m to the n, b sub 1 m to the n minus 1, plus b sub 2 m to the n minus 2, plus plus b sub n minus 1, m plus b sub n equal to 0. So meaning, all you have to do is to replace d by m, removing y, and then equal to 0. So we call this auxiliary or characteristic equation. It is actually a polynomial equation in M. And we call this in DE auxiliary or characteristic equation. And we will be calling this f of m equal to 0. Again, f of m equal to 0, meaning a polynomial function in M, and that is equal to 0. The solutions of f of m equal to 0 are called auxiliary or characteristic roots. So if you solve this, and then if you get roots, so they are called auxiliary or characteristic roots. The number of roots depends on the exponent of m or the order of the LDE. So yung exponent ng m, yun yung order sa LDE. Kung ang exponent ng m ay 3, expect that we have 3 roots. So they may be all real roots or 2 imaginary roots and 1 real root. Okay? If you have cubic equation. Now, you have to count the frequency. Sometimes, the roots are triple roots, meaning same. M equals 4, M equals 4, M equals 4. So, even it is, let's say, same root, so, but you have to count 3 times if it is cubic. Okay? So, the general solution of homogeneous LDE, f of d applied to y equal to 0, is given by y equals y sub c. Remember, the general solution of general LDE is y sub c, y equals y sub c, plus y sub p. But if the right side is 0, meaning if you have homogeneous LDE, y sub p is 0. So you have just y sub c. So y equals y sub c. But what is y sub c? Y sub c is c sub 1y plus c sub 2 y sub 2. So again, c sub 1 y sub 1 plus c sub 2 y sub 2 plus c sub 3 y sub 3 plus plus c sub n y sub n. So the number of terms is equal to the number of roots or equal to the number exponent of m. Kung ang exponent ng m ay 3, so you have 3 terms. Kung ang exponent is 4, you have 4 terms, and so on. Where y sub c is called the complementary function or solution. Ang y sub p natin, ang tawag, a particular solution. Wala siyang arbitrary constants. Y sub c contains arbitrary constants equal to the order of the DE, ang bilang, or equal to the exponent of m. Okay? In the polynomial equation, which is the auxiliary equation. The general solution of homogeneous LDE, f of d applied to y equals to 0, depends on the nature of the roots of f of m equal to 0, leading to the following 4 cases of solutions. So these are the cases of solutions. Number 1, if the solutions that you will get distinct real roots. So this is case 1. Again, the solutions are distinct real roots. kung yun ay, let's say, equation of, of degree 4, so expect of how many roots? 4. And they must be all different real roots. Let's say 2, 4, negative 5, 7. None of them are the same. They are all different from each other. If you have a degree 3 for the auxiliary equation, expect of, let's say, 3 distinct real roots. If that is the case, so you have case 1, and this is the rule of forming the solution to the given DE. If the associated equation has a root that is real, distinct, so for every distinct real root, m equals a, that you can get out of f of m equal to 0, there corresponds a solution term of the form c e to the ax. This is how to form the solution. Sa bawat root, ang term mo sa solution mo is c e to the ax. Kaya kung may dalawa kang terms, meron kang c1 e to the a1x plus another root, let's say a sub 2, so plus c sub 2 e to the a sub 2x. Okay? So that will be your y, or your solution to the given homogeneous LDE f of d applied to y equal to 0. So example, so let's say after getting the auxiliary equation associated with the homogeneous LDE, so you get these roots. Pag sinolve niyo yung auxiliary equation, 2, negative 3, 5, ito yung naging roots. How to form solution, general solution to the corresponding linear DE, homogeneous linear DE. So y equals c sub 1 e to the 2x plus c sub 2 e to the negative 3x plus c sub 3 e to the 5x. Ilalagay nyo lang, all you have to do is to put these exponents to the, these numbers to the exponent of e, and then each is multiplied by x, no? Its exponent, okay? If your distinct roots are 0, negative 8, 3/4, so the general solution is what? Y equals c sub 1 e to the 0. But e to the 0 is 1. So they don't write it anymore. Again, you have 0. So c sub 1 e to the 0 x. So c1 e to the 0x means c sub 1. Plus c sub 2 raised to e to the negative 8x. And then plus c sub 3 e to the 3/4 of x. Okay, so e to the 3x over 4. So this is the general solution corresponding to the linear DE whose auxiliary roots are 0, negative 8, 3/4. What about if you have 1, 2, 3, 4, 5? How many? 1, 2, 3, 4, 5. There are 5 distinct real roots. So for the first term, c sub 1 e to the 4x plus c sub 2, second term, e to the negative 5x, c sub 3 e to the negative 1/2 of x, so or negative x over 2, plus c sub 4 e to the negative 3 plus square root of 2 multiplied to x, and then the last term, c sub 5 e to the negative 3 minus square root of 2 multiplied to x. Okay? Can you follow, guys? What about if you have case 2? Pag case 2 naman, so you have repeated real roots, meaning you have a root, let's say 4, but that is obtained 2 times. Like for instance, if you have an equation m squared minus 4m plus 4 equal to 0, the left side can be factored into m minus 2 quantity squared, and then that is equal to 0. So the root is m equals 2, but that is obtained 2 times because it is quadratic. So it is one root, but the frequency twice, okay? Or 2 times. So for every real root, m equals a of multiplicity k, meaning repeated k times, 2 times, 3 times, 4 times, that you can get out of f of m equal to 0. There corresponds as a sum of solution terms of the form c sub 1 e to the ax plus c sub 2x e to the ax. So, same always a plus c sub 3x squared e to the ax plus plus c sub k x to the k minus 1 e to the ax. So, when are you going to stop? Once you reach the number of times it is repeated. And as you notice, the power of x is increasing. So, for the first term, x has an exponent 0 until you get an exponent that is k minus 1 for the x. But your multiplier to every term, so we have e to the ax, where a is the exponent that is repeated, I mean the root that is repeated k times. Now, kung meron kang another root that is repeated, another like this. Okay? Now, in factored form, so this is same as c sub 1 plus c sub 2x plus c sub 3x squared all the way to c sub k x to the k minus 1, then multiply to e to the ax. Okay? Since e to the ax is common. So let us have an example. So for the general auxiliary roots, for the given auxiliary roots of a certain homogeneous LDE, determine the corresponding general solution. So let's say I have a root 2 but repeated 3 times. So meaning I obtained this from a cubic equation whose roots just the same, no, for the 3 roots. So repeated 3 times. You get 2, 2, 2, 2. No? So what is the general solution, guys? What do you think? Y equals c sub 1 plus c sub 2x plus c sub 3x squared. So you have 3 terms because there are 3, the frequency is 3 for the root 2. And then multiply 2 e to the 2x. So the exponent is 2. So e to the 2x, okay? So again, c1 plus c2x plus c sub 3x squared e to the 2x. But by the way, arrangement of terms does not matter. You can also have c sub 1x squared if you want, plus c sub 2x plus c sub 3. What about letter B? There are 2 sets of repeated roots. The first set 0, 0. The second set negative 3, negative 3, negative 3, negative 3. So the first set repeated 2 times and the root is 0. The root negative 3 is repeated 4 times. So you have 2 sets of what? Of the form described or given in the rule, no? So let's say 0, 0. So how to form solution for that? So you have 2 terms, c sub 1 e to the 0 plus c sub 2 x e to the 0, or that is c sub 1 plus c sub 2x multiplied 2 e to the 0. Okay? So, then for the next set, you have, because we already ended with 2, so the next now is c sub 3. So, be sure your arbitrary constants are different, no? So, we have already c sub 2, so we now start with c sub 3. And how many terms? 1, 2, 3, 4. There are 4 repeated roots. So, we have 4 terms also. 1, 2, 3, 4. With increasing powers sa coefficients ng arbitrary constants. So, c sub 3 plus c sub 4x plus c sub 5x squared plus c sub 6x cubed multiplied by e to the negative 3x, which is the negative 3. The repeated root, we have e to the negative 3x. Letter C. Sorry? Yung E? Ay, di ba yun nga yung rule? Hindi, nakalimutan na yung rule. Ito nga yung format o, ilalagay mo lang yan na yung solution. Ganyan ang format ng solution. Ilalagay mo lang sa E, yung exponent, yung root na na-repeat sa dulo, e to the whatever that repeated root A, multiply mo lang sa X. Binigay na nga yung format ng solution. Sasauluhin mo na lang yung format para madaling mag-solve. Remember, kung isosolve mo ng reduction of order in the video that you watched, ang haba niyan. Kaya nga, so this auxiliary method was introduced by what? By mathematician, so that you will not anymore undergo such long procedure. All you have to do is to get the auxiliary equation associated with the DE, solve for the roots, and once you have solved for the roots, apply nyo lang yung mga rule. Depende sa roots. Kung repeated, kung distinct. Kung repeated, ganyan ang pag-form. Yan. Okay? Kung naman distinct, yung kanina. Oh, what about letter C? Oh, yung ikaw, yung nagsagot kanina. Oh. Paano mag-form? Y equals what? Oh, for the first set, repeated 2 times. Oh, Y equals C1 plus C2x. Bakit wala ng E? What? Sorry? Bakit walang E dito? E to the 0. E to the 0, 1. E to the 0, x. E to the 0, x is 1. Kaya hindi na sinulat. Pag 0 ang root, hindi na sinusulat ang E. O, yung susunod na set, how many times it is repeated? How many times it is repeated? 3. Oh, how many terms do you expect bago mag-multiply ng E? How many terms? 3. Oh, what is the first term? Oh, what is the first term? C sub 3. Baka may C sub 2 na rito. C sub 3. Anong susunod na term? C sub 4x. Then C sub 5 x squared na. Yan, tatlong terms. Then multiply mo lang ng e to the yung exponent ng e, yung negative 2/3. So negative 2/3 of x or negative 2x over 3. Oh, what about the third set? How many times it is repeated? 2 times. So what do you expect? How many terms? 2. So we now have C sub 6 kasi C sub 5 na to. C sub 6 plus C sub 7x multiplied by e to the square root of 3x. O ganyan lang mag-form ng solution. Ang dali. Okay? Third case. Ito pag-form pa lang ng solution na later actual DE nang ibibigay sa inyo. You will be given the actual DE. What if the roots that you will get, imaginary roots? Pag imaginary roots, pag nag-solve kayo ng polynomial equations na imaginary roots, laging they always come in pair. Okay? So let's say quadratic equation, imaginary root, kung ang root mo ay 2i, laging negative 2i is also a root. If you get 2 plus i, 2 minus i is also a root. Always come as conjugate pairs. Okay? Laging conjugate pairs ang nakukuha. Yan. So for every distinct pair of imaginary roots, different pairs, for every distinct pair of imaginary roots of the form m equals a plus or minus bi that you can get out of f of m equal to 0, there corresponds a sum of solution terms of the form. Diba, binigay ko na yung form dati from the sa yung idea natin. You have what in terms of sine cosine. So you have c1 e to the ax. O, saan nang galing yung a? Sa first term ng solution ng imaginary pair. At yung b, saan nang galing? Sa coefficient ng i. Meaning yung second term, yung b, yung coefficient ng i. You are going to put in the argument ng cosine at sine. Okay? So yung b. So you have c sub 1 e to the ax, cosine bx, plus c sub 2 e to the ax, e to the ax sin bx. Laging ganyan ang format ng bawat pair na makukuha nyo. Or, in factored form, because e to the ax is common, you have e to the ax multiply 2c1 cosine bx plus c sub 2 sin bx. Laging ganyan ang format ng solution. So let's say, we have the roots. Ito yung nakuha yung roots. Isang pair. So, ilang terms ang ina-expect natin? 2 terms. So, general solution, yung sa loob, ito yung 2 terms. C sub 1 cosine 3x plus C sub 2 sin 3x multiplied by e to the 2x. So where did I get the 2? From the first term in the solution, no? And then yung 3, coefficient ng x in the angle ng cosine at sine 3 ng sine, yung 3. So ang coefficient ng x is 3, yung which is the coefficient ng I in the roots. Okay? So in these roots, yung coefficient ng I. Okay now, guys? What if your root is plus or minus 3i? Kung plus or minus 3i, ang ibig sabihin lang A0. 0 plus or minus 3i. Again, pag walang real part, it means the real part is 0. So kapag 0 ang real part, wala nang E. So yung first set, sa first set, you have C sub 1 cosine 3x, so 3x, plus C sub 2 sine 3x. Ganyan lagi ang pagpo-form ng solution. For the second set, dahil may real part na A, negative 2, so ano ang B? 1. Ang B natin 1. Ang A, negative 2. So, e to the negative 2x, e to the ax. So, negative e to the negative 2x, multiply 2c sub 3 cosine 1x plus c sub 4 sine 1x. Letter C, negative 1 plus or minus 4i. So, this is the first pair. The second pair, 1/2 plus or minus 7i. Third pair, square root of 2 plus or minus square root of 3 over 2i. So we have 3 sets. So general solution for the first set, e to the negative 1x. So for the angle, ang coefficient ng x, 4. So C1 cosine 4x plus C2 sine 4x. What do you expect for the second set? Ano ang second set sa solution, general solution, guys? E to the plus what? E to the, okay guys, e to the 1/2 of x, no? Multiply 2. Multiply to what? Guys, multiply to what? Si sub 1 muna, si sub. Si what? Si sub ano? Si sub 3. Si sub 3 cosine what? 7x plus si sub 4 sine 7x. Okay? Yan. Then, e to the square root of 2x is, is e to the square root of 2 multiply 2x times, that is square root of 2. C sub 5 cosine of square root of 3 over 2 of x plus C sub 6 sine of square root of 3 over 2 of x. Okay? Yan. What about case 4? Ang case 4, extension lang yan ng case 3. Na-repeat naman yung bawat pair ng imaginary roots. Halimbawa, 2 plus 3i, 2 plus or minus 3i, plus meron uling 2 plus or minus 3i. Na-repeat. So, pag ganun ang case, so, ito naman yung rule. For every pair of imaginary roots, m equals a plus or minus bi of multiplicity k of f of m equal to 0, meaning repeated k times, there corresponds a sum of solution terms of the form. So, anong form? We have e to the a1x, c sub 1 cosine bx plus c sub 2 sine bx. Dahil na-repeat, uulitin mo lang to, papalitan mo lang yung c sub 1, c sub 2 ng c sub 3, c sub 4, pero magkaka-x na. May multiplier kang x. At yung pangatlo, x squared. Pero ang sa arbitrary mo, c sub 5, c sub 6, hanggang makarating ka ng last term. Ang last term, ang bilang actually ng terms or group na gagawin mo, kung depending on the number of times it is repeated. Kung repeated 2 times, hanggang 2 groups ka lang. Itong first group na to plus another group. Pag 3 times na repeat, hanggang third group. Pag third group, ang multiplier mo ay x squared. Pag fourth group, ang multiplier mo x cubed. Pag k group, ang multiplier mo ay x to the k minus 1. Okay? Yan. So, let's see. So let's say your auxiliary roots 2 plus or minus 3i, but that is repeated how many times? This pair. This pair is repeated 2 times. So expect that there are 2 groups in the general solution. The first group, e to the 2x, c1 cosine 3x plus c2 sine 3x. The second group, repeat mo lang yan. Multiply mo lang ng x. So, plus x, e to the 2x. Pero yung arbitrary mo, c3 na at saka c4. That's it. What if your auxiliary roots repeated how many times? Yung first group repeated 2 times. Yung second group repeated 2 times. Kaya meron tayong 2 sets ng repeated imaginary pairs. O yung unang group muna, unang set na repeated 2 times. So we have C1 cosine 3x. Bakit walang E? Kasi 0 ang real part. If the real part is 0, so e to the 0, that's not written anymore because it is equal to 1. So c sub 1 cosine 3x plus c sub 2 sine 3x. Dahil repeated 2 times, so you have another like this. So change nyo lang yung arbitrary at multiply nyo lang ng x. So x, c sub 3 cosine 3x plus c sub 4 sine 3x. Yung second group naman, so ulit-ulit. So yung wala munang x, yan, pero you have e to the negative 2x, then c sub 5 cosine x plus c sub 6 sine x. Dahil na-repeat 2 times, another like this. Multiply mo lang ng x. And then arbitrary now, 7 tsaka 8. Okay? Okay, niyo follow guys? Pag hindi makapalo, ibig sabihin, mahina ang ulo. Oo. Slow. No? Considering that it is very easy to actually to follow. O letter C. Unless you did not watch the video thoroughly or seriously. So how many groups do we have? 1, 2, this is, the first group is repeated 1, 2, 3 na? Repeated 3 times yung first group. Yung second group, repeated 2 times na? Paras lang to no? Repeated 2 times. So, dalawang groups. Dalawang beses natin i-apply yung rule number 4. Okay? So, first group muna. By the way, kahit saan ka magsimulang group, okay lang. Yung arrangement ng arbitrary, okay lang, ha? Kahit actually ang ilagay mo yan, C sub 100, C sub 101, C sub 102, 103, kahit actually hindi sunod-sunod. 7, 8, 9, 10, 11, 12, kahit anong arbitrary. Kaya lang maganda, kung may numbering na nagsimula sa 1, 2, 3, 4, hanggang, para madaling magbilang ng arbitrary. Kasi ang bilang ng arbitrary, yun ang bilang ng roots. O ilang roots meron tayo? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So expect that there are 10 arbitrary constants para as checking. Pag nagkulang, it means may mali ka. O yung first group muna, repeated how many times? 1, 2, 3. So expect na there are 3 groups in the first set, na? O, then multiply lang natin ng x. C sub 3 na, C sub 4, no? Here. Then isa pa, no? Multiply ng x squared naman. Pero, C sub 5 na, C sub 6. And then second group, ito na. Another, simula na uli. Apply again the rule. So, wala mo ng x. E to the 3x over 5. O, yun yung a, 3 over 5. Then, C sub 7 na tayo. At yung argument, square root of 2 multiplied to x. Yan, yung coefficient ng I in the root, no? Then, multiply by x. So, copy lang. O, yan. 9, 10 na tayo. C9, C sub 10. Okay? O, alam na mag-form, children. O, you are now ready to solve DE. Okay? O, let's now have. By the way, combination of cases. Give you an example of combination of cases. So we have, for the given auxiliary roots of a certain HLDE, determine the corresponding general solution. O yan, yung first two, case 1. Why case 1? Distinct. Yung second group, negative 5, negative 5, negative 5, is case 2. Repeated real roots. Kaya apply natin 2 rules. Rule number 1, for rule number 1 muna, case Ito, cases 1 and 2 ha. O rule number 1 or case number 1. So sa 2 negative 3, si 1 e to the 2x plus si sa 2 e to the negative 3x. Para yan sa 2 negative 3, case 1 or rule number 1. Sa rule number 2 or case 2, so tatlong terms, C3, C sub 4x, C sub 5x squared, multiplied by e to the negative 5x. So that's it. What if you have distinct real roots saka imaginary pair? Rule case 1 and case 3. Case 1 muna tayo. C sub 1 e to the 2x over 5 plus C sub 2 e to the negative 2x over 5. Don't forget ha, laging may x ang exponent ha, times dun sa root. Then e to the negative 2x, dahil imaginary pair, e to the negative 2x, then multiply to c sub 3 cosine x, so 1x, plus c sub 4 sine x. Okay? O letter C. Anong mga case yan, children? Yung 2, what case? Ha? Yung 2 muna, what case is 2? Case? Negative 4 plus or minus 3i. Case? Yung etong negative 4 plus or minus 3i, what case? Etong last 2. Magkaiba yan eh. Ito negative 4 plus or minus 3i. Ito 4 plus or minus 3i. 4 plus or minus 3i. So yung last 2 roots, last 2 group roots, ano to? Case ano to? What case? Case 4. Kaya case 2, case 3, case 4. Don't forget ha. Be careful with this. Magkaiba yung negative 4 plus or minus 3i sa 4 plus or minus 3i ha. Kaya yan ay hiwalay. Isang pair lang to. Yung last 2 pairs pero repeated. 2, 3, and 4. Yung case 2, C1 plus C2x multiplied by e to the 2x. Case 3, e to the negative 4x, C3 cosine 3x plus C4 sine 3x. Yung last 2, repeated. So, una muna, walang x, e to the 4x, C sub 5 cosine 3x plus C sub 6 sine 3x. Then yung isa, may x na. Then C sub 7 cosine 3x, C sub 8 sine 3x. Okay? So, possible na combination ng cases ang magiging auxiliary roots nyo. Okay, so, may letter D pa. Letter D, case 1, case 1 din to, 2, negative 4, ito case 1, 3, 3, 3, 1, 2, 3, 3, 3, 3, case 2, case 2 rin itong 1, 1, no? Ito, case 3, ito, yung last. Case 3 din, no? Case 1, 2, and 3. Look at how the solution terms are formed. Ito yung solution terms. Yan. Okay now, guys? Tingnan natin, baka meron pa. Ilan bang roots yan? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Kaya hanggang 11. C11. May ipa. Dahil pala dito. Cases ano yan? 1, 2, and 4. 1, case 1, case 1. Ito, case 2, negative 2, negative 2. 1, 2, 3, 4, 5. Case 2 pa rin to. Ito, case 4. Yung last. Pero, ang real part, 0. Kaya walang E. Ito, walang E din yung unang term. Kasi 0 eh. Yan. Second term. Third term repeated. So, C sub 3 plus C sub 4x e to the negative 2x. Repeated ulit. 1, 2, 3, 4, 5. So, 5 terms. C sub 5, 6, C sub 6, C sub 7, C sub 8, C sub 9. 1, 2, 3, 4, 5. E to the 3x. And then, last case, case 4, wala munang x. Bakit walang e? Kasi 0 ang real part. Then, walang x. Susunod, may x na. Okay? Ilang roots? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Meron pa kaya to? Meron pa? Kailan ba ito matapos? Cases 1, 2, 3, and 4. Ayan, check nyo na lang. O, for first two roots, distinct. O, next, repeated 3 times. So, sisa 3, sisa 4x, sisa 4, then times x plus sisa 5x squared. Walang e kasi 0 yung exponent ng e. And then, third case. Third case to na. So, we have e to the negative 2x is sub 6 cosine 5x is sub 7 sine 5x. Ito, 1, 2, 3. Repeated 3 times. Case 4. Una, walang x. Pangalawa, may x. Pangatlo, may x squared. Okay? Question guys. Siguro naman tapos na to dyan. May ano na to. DE na to. Yan, solving na DE. What time is it guys now?
9:56 po.
9:56. Ito actual DE na. Solve each of the following homogeneous LDE. O letter A. O letter A muna tayo. Y double prime plus 6y prime minus 7y equal to 0. In D notation, you have D squared plus 6D minus 7 applied to y equal to 0. You should know how to express it in D notation ha. Pag may y prime, may D. Pag walang y prime, y lang, constant lang yon. Then, lalabas nyo sa dulo yung y. Auxiliary equation, m squared plus 6m minus 7 equal to 0. What are the roots? In factored form, m plus 7m minus 1 then equal to 0. For the first root, negative 7. Second root, 1. Oh, what are they? Distinct, repeated, imaginary pair, repeated imaginary pair. Guys,
Ano sir? 1 po.
anong 1? Distinct. So, meaning case 1 yung sinasabi nyo. Case 1. O, paano mag-form ng case 1 ng solution? So, itong auxiliary roots, no? Negative 7, 1. So, y therefore is equal to, ano dyan ang solution ng DE? C sub 1 e to the negative 7x plus C sub 2 e to the x. So, see? Very easy to form the solution rather than reduction of order. In the previous video, sinolve yan ng reduction of order. So, a little bit long. O, ito, solve nyo lang yung auxiliary equations, yung roots ng auxiliary equation, you will now get the general solution. As long as you know cases 1, 2, 3, and 4 rules. Yan si Goldie. Yan si Goldie. O, letter B. O, what is the associated equation? What is the auxiliary equation for that, children? That is already in D notation. O, what is the auxiliary equation, guys? Ha, guys? By the way, wag kayong magkokopyahan yung mga solution nyo pare-pareho. Hindi lang ako naawa sa inyo, papadiyo ko kayo. Hindi naman ako nagbabaksak ngayong pandemic. Pagdating ng finals, I will adjust. Basta submit ang lahat ng requirements. Pero pag may kulang na requirements at baksak, di nag-submit, ayan. Merong hindi nagsasubmit, 2 lang yata yun o 3. Pero hindi na yata pumapasok. Oh guys, what is the auxiliary equation? Guys, what is the auxiliary equation? Okay guys, ano ba itong mga ito na pipipi lagi pag tinatanong? Guys, are you still there? Okay guys. Ano auxiliary equation? Oh, ano auxiliary equation? 3 m squared minus 4m. Okay? Oh, factor out m. So we get m, 3m minus 4 equal to 0. Oh, what are the roots? 0. And then the other root, 4/3. Oh, what are the auxiliary roots? 0 and 4/3. Oh, what is the solution? to the given D is C sub 1, y equals C sub 1 plus C sub 2, e to the 4/3 of x. So meaning 4x over 3. Okay guys? Letter C. Oh. Yan, verified by Goldie. Si Goldie ang nagbe-verify kung tama. So y double prime minus 6y prime plus 9y equal to 0. In D notation, d squared minus 6d plus 9 applied to y equal to 0. Hindi yan multiplied by y ha. d squared minus 6d plus 9 applied to y equal to 0. Auxiliary equation, m squared minus 6m plus 9 equal to 0. M minus 3 quantity squared equals to 0. M ang ginagamit natin na pag gumamit kayo ng ibang letter, hindi ko na chechikan. Ibig sabihin, hindi kayo nakinig. Nangopya lang kung saan-saan. Nag-google lang. So, repeated. Ang root niyan, repeated 2 times. M minus 3 equal to 0. So, M equals 3, but that is repeated 2 times. Multiplicity of 2. So, case 2. So, ang roots, 3, 3. Or 3 repeated 2 times. So, case 2. Paano mag-form ng case 2? What is the general solution, guys? Y equals? Guys. Y equals C sub 1 e to the 3x plus C sub 2x e to the 3x. Okay? Pwede rin naka-factored form. C sub 1 plus C sub 2x quantity e to the 3x. Ito yung factored form. Okay, guys? Pag repeated, may namumultiply na x sa susunod. At pag may pangatlo, x squared. Pag may pang-apat, x cubed. Verified by Goldie. What about that? The 4d squared plus 28d plus 49 applied to y equal to 0. Auxiliary equation. 4m squared plus 28m plus 49 equals 0. That is factorable into m2m plus 7 quantity squared. Just that left side. Then equal to 0. So we have 7 over 2, negative 7 over 2. Repeated how many times? 2 times. So auxiliary roots is negative 7 over 2, negative 7 over 2. So that we have a solution, y equals c sub 1 plus c sub 2x multiply 2 e to the negative 7x over 2. Okay? Ayan, verified by Goldie. What about letter E? Y double prime plus 4y prime plus 29, y equal to 0. In D notation, d squared plus 4d plus 29 applied to y equal to 0. Auxiliary equation, m squared plus 4m plus 29 equal to 0. How to solve that quadratic? Maraming technique. You can use quadratic formula. So I use here completing the square. So transpose 29 on the right side, negative 29. Add on each side 4. Then the left side now is m plus 2 quantity squared. And the right side negative 25. Taking the square root of each side, we have m plus 2 equals plus or minus 5i. So m therefore is negative 2 plus or minus 5i. What type of roots are these? What type? Case 3, imaginary pair. There is only one pair, therefore, one group lang, no? So, C sub 1 cosine 5x plus C sub 2 sine 5x. Ano ang multiplier natin? E to the 2, negative 2x, no? Yan. Okay? Di ba? Very easy mag-solve kaysa yung mga first order, first degree ODE. Letter F. 4d squared minus 12d plus 15y applied to y equal to 0. Auxiliary equation. 4m squared minus 12m plus 15 equal to 0. By completing the square. So, plus 9. Plus 9. Nagkataong 2m minus 3 quantity squared to, ha? By the way, kanya-kanyang technique yan ang pag-solve ng quadratic equation na. Kung hindi nyo kaya ang ganitong technique, you can use quadratic formula. Taking the square root of its side, we have 2m minus 3 equals plus or minus square root of 6i. O what is m? 3 plus or minus square root of 6i all over 2. Yan, divide ng 2. Okay? Auxiliary roots, this pair, no? 3 plus or 3 over 2 plus or minus square root of 6 over 2i. Case 3. Pero, isang pair lang yan. Kaya, y equals e to the 3x over 2 multiplied to c1 cosine square root of 6 over 2 times x c sub 2 sine of square root of 6 over 2 of x. Okay? O, example 7. So, perhaps ito medyo complicated na. Solve the homogeneous LDE d squared minus 8d plus 17 applied to y equal, quantity squared applied to y equal to 0. Solution. So, auxiliary equation corresponding to this, m squared minus 8m plus 17 quantity squared equals 0. O, let's solve yung inside. Yung inside ay m squared minus 8m plus 17 plus 16 plus 16. I transpose 17 on the right, then plus 16 plus 16. So it is now m minus 4 quantity squared equals negative 1. So m equals, m minus 4 is plus or minus I. What is m? 4 plus or minus I. But this is repeated how many times? Kasi kinuha ko lang to dun sa loob. Naka-square siya. So repeated 2 times. Don't forget that ha. Ang degree kasi nito 4. Kaya dapat 4 ang roots. Ito 2 na. Plus kasi repeated another 2. So 4 all in all. Kaya lang this repeated pair 2 times, no? Okay? Don't forget that ha. So auxiliary roots plus 4 plus or minus I, 4 plus or minus I. So meron tayong multiplier na x sa second group, no? So how to form the solution? So y equals e to the 4x, c1 cosine x plus c sub 2 sine x, yung coefficient ng I, yung magiging coefficient ng x. Another group, may another group plus x, may multiplier lang ng x. So, kaya lang yung c sub 1, c sub 2, magiging c sub 3, c sub 4 na. Okay? Okay, niyo follow guys? O, let's see kung verified by Goldie. Yan. Example 8. Solve the homogeneous LDE d cubed plus 3d squared minus 4d plus 2, negative 12 applied to y equal to 0. This is cubic. So, the auxiliary equation associated. So, that's the homogeneous LDE. So, the associated auxiliary equation is cubic equation. And how to solve for the roots of this? Maraming technique. Kung factorable, you can do factoring by grouping. O kung hindi kaya, synthetic division. Okay? So, let's see what is applied here. So, factoring by grouping. So, for the first 2 terms, I factored out m squared. For the second 2 terms, so we have negative 4. I factored out negative 4. So to get m plus 3, the remaining factor. So m plus 3 is common. So factoring it out, I get m squared minus 4. So m plus 3 common, so m squared, then here minus 4. And this can still be factored. No? Pero pwede nang isolve to diretso. Padali na namang isolve yung m squared minus 4. So, m plus 3 equal to 0, m squared minus 4 equal to 0. So, negative 3 for the first root. Ito naman, plus or minus 2. Okay? Yan. So, anong auxiliary roots? Negative 3, positive negative 2. So, case 1, all the roots are distinct. So, case 1. So, what is the general solution? C1 e to the negative 3x. Ang right side, so y equals C sub 1 e to the negative 3x plus C sub 2 e to the 2x plus C sub 3 e to the negative 2x. Or see how case 1 is applied in here in solving this DE. Okay, guys? Still alive, guys?
Yes, Prof.
Let's see. Number 9. Solve the homogeneous LDE 2d to the 4th plus 3d cubed minus 14d squared minus 9d plus 18 applied to y equal to 0. Solution. So copy the given DE. This is homogeneous LDE. Why homogeneous? This is LDE whose right side is 0. Homogeneous. Auxiliary equation, 2m to the 4th plus 3m cubed minus 14m squared minus 9m plus 18 equal to 0. I think this is better to solve by synthetic division. We copy the coefficients. Be sure your left side is arranged from highest to lowest power. So, the coefficients 2, 3, negative 14, negative 9, 18. In case there is a missing power, you are going to have 0 for the coefficient. Okay? And then our number here, our multiplier is 1. So bring down, multiply by 1, so we get 2 here, add, we get 5, then multiply by 1, 5 times 1, 5, add, negative 9, multiply negative 9 by 1, this multiplier is 1. How did I get 1? Guys, trial and error yan. So, pero ang itatry yung number na multiplier here, yung mag-0 ang left side. Pag ang left side hindi nag-0 sa number na itatry nyo, do not try that number anymore. Let's say yung 1. How did I get 1? I tried it. I substituted to m. So, 2 times 1 plus 3 times 1, that is 5. Minus 14 times 1, that is negative 9. Then negative 9 times 1, negative 18. Plus 18, 0. So, this will work. This will really work, no? It will give a remainder 0 later. So, times negative 9 times 1 is negative 9, add negative 18. Times 1, negative 18, add 0. So, it means m minus 1 is a root later, ha? Remember, if m is a root of this, so m minus 1 is a factor. Let's try another one. Ang try ko 2. Okay? Try ko 2. Trial and error yan, ha? I hope you studied synthetic division in your lower math. Bring down 2, multiply by 2, so 4. Bring down, add 9, so multiply by 2. 18, add 9, multiply by 2, 18. So, 0. So, this is already quadratic. Madali na to eh, pag quadratic. Yan. 2m squared plus 9m plus 9 yan. Yung other factors, m minus 1, m minus 2. Pag 2 is a root, pag sinubstitute nyo 2 dyan, it will become 0, the left side. Pag nag-0, 2 is a root. So, m minus 1, m minus 2 are factors because 1 and 2 are roots. The other factor, 2m squared plus 9m plus 9. Okay? And this is still factorable into 2m plus 3, m plus 3. This 2m squared plus 9m plus 9. You just check, no? 3m, 6m, 9m. 3 times 3, 9. 2 times 1 is 2. So, what are the roots? 1, 2, negative 3 halves, negative 3. Yung arrangement ng roots, it doesn't matter, ha? Okay lang yan. Kahit anong arrangement ng terms. Kahit magkapalit-palit, kahit yan ang C1, kahit dito ang C3, C4, and so on. C1, so y equals C sub 1 e to the x, plus C sub 2 e to the 2x, C sub 3 e to the negative 3 halves x, then plus C sub 4 e to the negative 3x. So that's it. See? Okay, guys? Oh, parang all in one, no? Nag-algebra na kayo, nag nag ano pa tayo, nag DE. O number 10. Kailan ba 'to matapos? O d to the 6 minus d to the 5th minus 5d to the 4th plus 3d cubed plus 8d squared plus 4d applied to y equal to 0. This is the homogeneous LDE. What is the auxiliary equation? M squared, m to the 6 minus m to the 5th minus 5m to the 4th plus m cubed plus 8m squared plus 4m equal to 0. Factoring out m. Apply synthetic division to the remaining factor. So 1, negative 1, negative 5, 1, 8, 4. Try ko. Let's say, ang tinry ko negative 1. Substitute sa ang negative 1 sa m to the 5th minus m to the 4th and so on. Pag sinubstitute yan, negative 1 minus 1, 0, 0. Ay, negative 2. Then, plus 5 to kasi negative 1 to eh. Plus 5, 3. Plus 1, 4. Minus 8, negative 4 plus 4, 0. So, negative 1 is a root, m plus 1 is a factor. So, bring down 1, multiply by negative 1, add, 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 multiply by negative 1, add. See? If the last will not become 0, you got a mistake in the multiplier. Or you have a wrong operation perhaps. Let's try another one. Pwede pa ba yung negative 1? Pwede pa actually. Dito ka mag-try. Ito ibig sabihin ni m squared minus 2m ay m to the 4th minus 2m cubed minus 3m squared. Ulit. M to the 4th minus 2m cubed minus 3m squared plus 3m plus 4. I-substitute mo yung negative 1 sa m dito. So, ang makuha nyo uli negative ay 0. If that is the case, negative 1 is another root, no? 1. Bring down, multiply, add, multiply, add, multiply, so 0. Add 4, multiply negative 4. Then add 0. Okay, guys? Yan. What about here? I-apply naman natin. Negative 1, pwede uli. Ang ibig sabihin nito, m cubed minus 3m squared plus 0m plus 4 plus 4. Multiply, add, multiply, add, multiply. Nag-0 uli. Kaya, negative 1 will also work. Ito na, pwede na to, quadratic na to, madali nang i-handle yan. That is factorable into m minus 2 quantity squared. So, ano ang mga root? 0. Ito, negative 1, negative 1, negative 1, kasi quantity cube. Ito, 2, 2, 2, kasi quantity squared. 1, 2, 3, 4, 5, 6. So, for the first one, this is distinct. Case 1, ito, case 2, pareho, no? Cases 1 and 2, therefore. Case 1, itong C1 e to the 0. So, C1. Itong case 2, C sub 2 plus C sub 3x plus C sub 4x squared e to the negative x. Then sa 2, 2, C sub 5 plus C sub 6x e to the 2x. Okay, guys? Okay, guys. Naku, nag-aalmasal na yata yung iba. Number 11. Solve the homogeneous LDE for d to the 7 minus 31d to the 5th plus 56d cubed plus 16d applied to y equal to 0. Okay. So, 4d to the 7 minus 31d to the 5th plus 56d cubed plus 16d applied to y equal to 0. That's the homogeneous LDE. Auxiliary equation. 4m to the 7 minus 31m to the 5th plus 56m cubed plus 16m equal to 0. Factoring out m, we get 4m to the 6 minus 31m to the 4th plus 56m squared plus 16, the other factor. Okay? So again, synthetic division. So 4, bring down. By the way, our multiplier is 2. You can substitute 2 here sa 4m to the 6 minus 31m to the 4 plus 56m squared plus 16. You will able to verify that this will make it 0. So m equals 2 is a root, m minus 2 is a factor. So 4 times 2, 8. 4 times 2, 8. So, add 8, multiply by 2, 16, add, negative 15, multiply by 2, negative 30, add, negative 30, multiply by negative 2, negative 60, add, negative 4, multiply by 2, negative 8, add, negative 8 times 2, negative 16, add, 0. Oh, see? 2 is really a root, m minus 2 is a factor. Oh, ano pang itatry natin? 2. Oh, I tried 2 again. Pero dito kayo mag-substitute sa 4, m to the 5th plus 8m to the 4th minus 15m cubed minus 30m squared minus 4m minus 8. Pag sinubstitute nyo sa m, magsi-0 yan. Bring down, multiply by 2, 8, add 16, multiply by 2, 32, add positive 17, multiply by 2, 34, add 4, multiply by 2, 8, add 4 multiply by 2, 8. Add 0. Try again. What number? I tried negative 2. So, negative 2, pag sinubstitute nyo dito, sa 4m, ano na ba to? Ito ay 5, ito ay 4. M to the 4 plus 16m squared plus 17m plus 4 ay 17m 4m to the 4 plus 16m cubed plus 17m plus 4, 17m squared plus 4m plus 4. Pag sinubstitute yung negative 2 sa m, 0. Actually, pwede rin dito. Kahit dito sa original. Pag sinubstitute yung negative 2 is still 0. So, meaning m plus 2 is a factor, m equals negative 2 is a root. So, bring down, multiply by 2, negative 2, 8, negative 8, add 8, multiply by negative 2, negative 16, add 1, multiply, negative 2, add 2, multiply, negative 4, add 0. Okay? So, we now have, kailan kaya matap? So, yung 4812, yan, ito yon. This is factorable by what? Grouping. I applied factoring by grouping sa last. Ang ibig sabihin ng 4812, yun ay 4m cubed plus 8m squared plus m plus 2. So, m plus 2 is common. Yan, that is the factored form. Hence, the total factored form is m minus 2 quantity squared, m plus 2 quantity squared, 4m squared plus 1. Bakit m plus 2 quantity squared? Kasi may m plus 2 na kanina. May m plus 2 pa rito. Okay? Yung m plus 2 galing yan sa negative 2. So, ano auxiliary roots? M sa 0. Sa m minus 2, quantity squared, 2, 2. Sa m plus 2, quantity squared, negative 2, negative 2. Dito sa 4m squared plus 1, that is negative 1 over 4, negative 1/4 is square root, plus or minus 2, 1 half I. Cases 1, 2, and 3. That's it. C1 plus C2 plus C sub 3x e to the 2x plus C sub 4 plus C sub 5x e to the negative 2x plus C sub 6 cosine of 1 half x plus C sub 7 sine of 1 half x. Okay guys? Dahil wala tong real part, tong imaginary, kaya walang e. Guys, still alive guys?
Yes po, sir.
I think class na tong 12. Solve the homogeneous LDE. That's the associated auxiliary equation, m to the 6 plus 6m to the 4 plus 9m squared plus 4 equal to 0. Dahil lahat ng coefficients ng ng M, tsaka yung constant positive, at lahat ng M is even ang power, whatever you do to the M, pag nag-substitute kayo ng any real number, kahit negative, kahit positive, hindi yan magsi-zero. So, ibig sabihin, ang roots nito, puro imaginary. Kita nyo, pag negative ang sinubstitute nyo sa M, dahil nakaraise sa bawat even yung M, ang M nakaraise sa even, lahat ng M, so it will never be zero. Kaya wala kayong matatry na number dyan na magsi-zero yan. Ang technique, ilet nyo yung M squared ng N. Kasi ang laki, ang hirap i-factor niyan. So, N equals M squared. So, magiging ang equation in N cubed, kasi N squared quantity cubed to eh. So, N cubed plus 6N squared. Ito, plus 9N. Then, plus 4. O, yung N natin, ang isosolve natin, hindi muna yung M. O, ito, may add na yan. May add power na pwede nang mag-substitute ng negative. Kasi lahat yan positive. Huwag na kayo magsasubstitute ng positive. Negative ang itatry nyo na. You try negative kasi ang goal nyo mag-zero. O, try natin ang negative 1. Negative 1 plus 6 times 1, that is 5. Plus negative 9, negative 4. Plus 4, 0. Bring down, multiply, add, multiply, add, multiply, 0. O, quadratic na to. Madali na yan. N plus 1, N squared plus 5N plus 4. N plus 1, ito ang factored form, N plus 1, N plus 4. So, ano na ang factored form in terms of N? N plus 1, quantity squared, N plus 4 equal to 0. Ang roots ng N sa N, negative 1, multiplicity 2, tsaka negative 4. Pero, ang M ang gusto natin. Alam na natin ang N. So, kapag ang N ay M squared equals negative 1, ano ang M? Plus or minus I. Pero multiplicity of 2, kasi multiplicity of 2 ang negative 1. Multiplicity 2 rin ang plus or minus I. Yung N equals negative 4, M squared equals negative 4. Dahil yan yung N, M equals M squared. So what is M? Plus or minus 2I. So ano na ang auxiliary roots? Sa M. Remember, M ang sinusolve talaga natin. Plus or minus 2I, plus I, plus or minus I, plus or minus I. Cases 3 and 4. So, solution. Sa plus or minus 2i case 3, so C1 cosine 2x plus C2 sin 2x. Walang E kasi ang real part 0. Wala ring itong susunod na group kasi real part 0. So, wala mo ng x, C sub 3 cosine x plus C sub 4 sin x. Yung susunod may x na. Okay? Pero C5 tsaka C6 na. O, question guys. O, meron pa. Ang number, dahil wala na tayong time, yan. You just read. Ano lang naman to? Particular solution. So, solve nyo yung C1, C2. Pag nasolve na yung general solution, yan yung general solution. So, solve nyo yung C1, C2, and C3. Applying the condition. When x is 0, ang y prime daw is 5. When x is 0, ang y double prime is negative 16. When y is 0, when x is 0, ang y equals negative 3. Sa substitute nyo lang, kukunin nyo ang y prime ng general solution, ito yung y prime, hanggang y double prime. Applying the conditions, ayan yung conditions, yung dito sa unang-una, ano daw ang y? Negative 3. Pag ang x ay 0, c sub 1 e to the negative 2 times 0, plus c sub 2 plus c sub 3 times 0. Di 0 na tong c sub 3. Ayan. C sub 1 plus C sub 2, dahil ito, 1, equals negative 3. Equation 1. Ang equation 2, saan naman manggagaling? Dito. Pag ang x ay 0, ang y prime daw ay 5. Yan. Sa-substitute nyo lang. Pag sinimplify ito, and then, yung last, ito yung second derivative na nakuha natin sa general solution. Kapag daw ang x ay 0, y double prime is negative 16. Masasolve nyo ng C1. Ano ang C1? Negative 4. Dahil alam niyo na ang C1, makakasolve ka na ng C2. From 1, negative 4 plus C2, ano na ang C2? 1. From 2, makakasolve ka na ng C3, negative 3. So, ang particular solution, y equals C1 e to the negative 2x plus C2 plus C3 negative 3 then times x. Yan ang solution. Okay? Okay guys, wala na yung number 4, basahin nyo na lang. Ganon din naman yan. Oh. Okay na guys, ang dami palang examples nito. Ayan. And then we get this. Ayan. Thank you for listening, not watching. You can watch it in the YouTube. Okay na guys, bye!